Hi and welcome back to Dad's RC Hangar on that Friday feeling. Friday feeling is a bit different today. Yes, we are not in the hangar, as you might see. And no, these are not my collection of lovely, lovely nitro motors. No, they are Alan of West UK. Is that right? Yeah. West UK. Yeah, June is the boss. She said it's right. West UK in sunny Kent. Not so sunny today, but we're in Kent nonetheless. So, as you know, I want to put a custom exhaust for my Spitfire, and this is the place where it's going to happen. Alan's going to build me a custom exhaust using one of the West engines that he's designed and built, not just like grabbing an engine, grabbing an exhaust. It's all going to be modified. So we're going to chat to Alan and we're going to get a bit of information from him. So without further ado, let's go. Right, this is Alan Greenfield, a bit of a hero when it comes to nitro engines and any kind of engines. He designs, builds, and he's been going since what age?
I started playing, my father bought me a lathe when I was 8.
Wow, okay.
I started making bits and pieces.
So what's this engine you got in your hands?
Right. This is a standard Gannett 15 made by George Nerd and Fred Muirhead.
Right.
And I won the first ever National Speed Championships with one of these looking like that.
This is fantastic.
Now, I won it really by default because John Taplin was running a prototype 15 diesel, Taplin 15 diesel.
Okay.
But he'd set his motor up at Herne Bay.
Right.
And we went to Birmingham, which is a lot higher, and the motor wouldn't run. Eventually we got the motor to run in the afternoon, but it went round like a drunken duck and I'd won the meeting. After the meeting we set the motor up properly and he beat my time.
Right, but that's done, is it? Done deal?
Yeah, so I came back and modified the motor from that one.
Look at this, I just want to show you this. I mean, look at this engine. I mean, so how I mean, this is what? This is a few petrol, it's not nitro, is it?
15cc petrol.
15cc, 4-stroke petrol, look at this. So what year would this have come out in? 1970?
Oh, no, that motor came out about 54.
1954. I mean, look at that. Open to, I mean, I'm not doing it justice here. But this is Dad's RC Hangar, raw as hell. Okay, and what's this? You got, this is the one you modified.
This is one I came back and modified this. This was the original engine that I won the Nationals with. Right. And made a new head, new carburettor, and instead of having inclined valves, I used inclined ports, which gives you the same effect. And the following year, I won the Nationals using this motor against John with his motor set up properly.
So wow. So how much did you improve it by? How much?
I had no figures at that time, but it was a noticeable improvement.
Yeah, look at this. Look at this. I don't know if you can see that they made in. Look at that piece of history right in my hands. Absolutely fantastic. Well done. And how old did you when you did this?
About 11.
11 years old. Well, I'll tell you what I'm going to do then. I want to show you the rest of the engines. They're all prototypes, so you're probably the first people to see these. I'm going to take it off the thingy, whatever it's on, the stand, and then we're going to go a bit deeper because the phone's about to go as well. Who's done this motorbike?
I built it.
You built that motorbike?
Yeah. It's got a diesel.
Right.
That runs backwards.
Backwards? A backwards diesel? Let's have a quick
backwards diesel.
I'm the worst cameraman, so I can only apologise to everyone that's watching this, but we'll come back and do another one. But explain a bit about this then. Why is it backwards?
Because I'm using this system here, where you've got a pulley for the belt, because we was the first person to use belt drive on a model motorbike.
Was you really?
Everybody at the time was using a chain.
Yeah.
Which is quite heavy. So to get it going, there's a lot of inertia needed to get it going. So
a belt drive is sort of almost immediate.
Yeah, it's a lot lighter.
Wow.
And the problem with the bikes I found was trying to get the two forks balanced, because you've got sort of 1/2-inch diameter forks with a tiny shocker inside them.
Right.
So what I did was I put a decent sized shocker there and had swinging arm on the front with a steerable hub.
Now this is all sort of stuff that's on today's bikes, a lot of today's bikes, aren't they?
Yeah.
I mean, did they steal that from you, or did you tell them about it?
No, this was, I think we did this 2006, 7, something
Right.
like that.
Look at that.
And it uses, because it's using the Super Hunter, it's got a throttled exhaust on it,
Right.
so which keeps the temperature up.
Yeah, because you were saying that to me earlier, wasn't you, about,
Yeah.
you know, they can stall quite easily.
Yeah, and also the way I have always done my clutches is the wrong way round to everybody else. Most people on cars and everything will have the motor, then the flywheel, then the clutch, then the gear.
Right.
So the gear that's driving everything is as far away from the bearing as you can get. With this one, the gear is right next to the bearing.
Right.
Inside the flywheel, you've got the clutch
It just pulls it away.
and centrifugal clutch. But what you've got is easy start. You just put your normal starter cone on there.
And away you go.
Whereas most people are starting it from behind.
Yeah.
So it means you've got more bearings, more junk going around inside the motor. Whereas doing it that way, when I did that,
Fascinating.
that system originally in the late 60s when I got involved in IC cars.
That is amazing. I mean, Alan calls this his junk cupboard. I mean, but to those of you in the know, that is not junk. I mean, we've got, I don't know what models, what engine types of engines are over there. I wouldn't know, but that is fantastic. Now we're going to go into a bit more about diesel, because West engines that Alan designs and builds, he's got diesel ones, so we're going to have a look at that in a minute. All right, so this is the prototype shelf. So what's this, Alan? What am I looking at here?
This one is a twin 36, which I made just because I fancied doing it.
Look, hang on, there's the boss over in the corner over there. Say hello, June. I'm giving them money, don't worry. Oh, God, they want me money. Go on. Sorry, Alan, go on.
So this is two West 36 V1s,
Right.
which do about 23,000 on the ground. So I geared two of them together. The reason they're facing that way is because with the gear, you can now run the prop in the normal way.
Wow, that is serious engine. And how far? I mean, has this been on a plane? You put this on? No, just bench tested.
I've run it on the bench, and it is quite awesome hearing a motor doing sort of 46,000 plus.
From this exhaust, I mean, that's some type of exhaust. I mean, look at that. Oh wow, look at that. Who said German engineering is the best? Look at this, what Alan's done. Wow, fantastic. Okay, what else have we got on there? What are you actually proud of? I mean, there is a lot of stuff.
Well, I'm not proud of anything, really.
You should be. Where's the turbocharged one you're talking about?
This I did as a military project for killing AIDs.
All right.
Again, as normal with the military stuff, they wanted a robot electric to run for an hour.
Right.
Not a problem. So then they say, well, it'd be good if it had run for 8 hours.
So there's fuel.
So what we did, this had to fit. You can see it's rounded on the top.
Yep.
The idea was it had to fit down a tube, which was what the robot was made out of.
Right.
Generator on the front. Now, if there was enough battery power, you could use the motor to start the
engine, yeah.
motor, which is basically a West 36.
Right.
If there was insufficient power, then you could put a starter in the side and start it up to then generate the battery.
And you designed this exhaust system as well?
Yeah.
Wow. Fascinating.
But again, it all had to fit down the tube.
And did they use it?
No, because it got cancelled.
Okay, as
which
they
is
do.
what happens.
Militaries tend to do that.
This one.
Now this is turbocharged, is it not?
No, this is supercharged.
Supercharged, I believe.
Right. Because with a twin, where the pistons are doing this,
Yep.
you've got a major crankcase problem.
Right.
Because when the pistons come out, on this one you're pulling in 1.6 cc's of air, then you're squashing it. So you have a very big crankcase vent, whereas if you induct into the crankcase, you now use that as a supercharger.
Wow.
Right, so this has got reed induction into the crankcase.
Sorry, we're stopping everyone from picking up the phone. Hang on, hang on, let's stop right there. Right, everyone stop ringing for at least 10 minutes. Alright, go on.
Take all the phones off.
Take the phones off you. There you go, the boss has spoken.
Right, so it's reed induction into the crankcase.
Right.
Now, because it's a 4-stroke, the pistons come out.
Yep.
And you're sucking in 1.6 cc's of air. Then you're compressing that, but you've only got one valve open. So you're not putting 100%
in it.
plus in it, because you've obviously got losses inside the case, but you are getting more in it than you would normally get. And then suck blow goes in the other cylinder.
So sort of how much would that improve that engine, do you think?
Oh, it was a noticeable improvement. Again, at that time I never had a proper dyno
or anything,
to do it. Now I've got a Pucker dyno, so I could test things.
But that would be fast.
This was probably 30 years ago plus.
Wow.
It was actually seen on, there was a program by called Model Magic.
Right.
And that starred on there at one time.
Well, you're starring on Dad's Aussie Hangar, that's all you need to know now. Oh, everything's falling over.
This was going to be a project. It's going to be a twin.
Right.
Because we're involved with a Spanish company that flies my Velocity and Magnums autonomously. So they just program the computer. It's fired off on a launcher.
Right.
Flies around, does everything.
Yep.
And they had this idea of doing skywriting with model aeroplanes.
Yeah.
Because if you've got 5 model aeroplanes in a line in the sky, if this one does a puff of smoke, then this one, then these two, then this and this, as it's going along, you've printed O in the air. So with that, with 5, you can dot matrixly print any word you want.
Yeah.
So they wanted it to fly for at least 3 or 4 hours. So a normal 2-stroke was out. And what I proposed was this, which is a 4-stroke, overhead rotary valves, but it was going to be a twin.
Jeez.
And using crank web induction into the crankcase, so that again we could supercharge it.
Yeah.
And if you let your brain go mad, you can then put pulleys on here, and you can get VTEC timing by adjusting the timing.
Absolutely crazy.
But the company in Spain was trying to get some funding from the EU, and that never happened. So I built that as a prototype to prove the valve system.
Prove the concept,
but they didn't get the money, so I didn't get the money, so we didn't go anywhere.
As you do. Well, you know, I'm sure you go into a lot of car makers. They've got a lot of concept cars and bits and pieces, which is the same as your concept engine.
This was when I bought RCV. I thought I'd build some twins.
Right.
I pinched the cylinder heads because I needed them. But that's a twin RCV.
Wow.
That's another twin RCV out of 2 90s.
Look at these, absolutely fantastic.
This is a petrol conversion which I've done. Did a few of those without in-cowl exhaust.
Wow.
Then we did some ducted fan motors.
I mean, look at this thing. I saw this earlier. Absolutely crazy.
So they worked okay. And then I built this one, which was from an original Webra crankcase that they did for an American company, but again it didn't go anywhere.
Right.
And I redesigned that, just used their basic crankcase, and that pulled my test down the workshop. That was quite an evil.
That was
machine.
a bit scary, I bet. That was one of the scariest moments. Oh, it wouldn't move me anyway. I mean, these things scare me anyway. I mean, I had one going in the hangar, and it was, yeah, interesting. What is this here that I'm looking
This
at?
is a Runtronic ignition system. Now we sell a lot of these. Most of them 18-to-1 for motorbikes that we do for models.
Right. Okay.
So standard receiver pack. Now I don't know whether it works because it's been sitting there.
Oh,
but as you can see,
wow.
right. Now the good thing with the Runtronic is you get no spark at low RPM. As soon as you get to 50 RPM,
Bang.
you get a spark.
That is crazy.
And that draws 200 milliamps. You get no spark up to 50 RPM.
Right.
From 50 RPM to 4000 RPM, you get 3 sparks within 1 degree of crankshaft rotation.
Wow.
And then from 4000 up to 60,000, you get stuck with 1 spark.
Okay. That is phenomenal. Wow. I mean, it'd blow my brains. I mean, there's people that watch this they're gonna be loving this to bits.
That was I did some development work on engines for Sen cars, and I used one of their 46s and built that just because I thought I'd build it.
Just because you can.
When I was into motorbikes, I built these 2 motorbike engines.
All right.
4-stroke, because we was the first one to put a 4-stroke in a motorbike, which I think it's still on YouTube somewhere. You can go and listen to this Ducati go round with one of these in it.
I bet that was loud.
Because we had a customer who came in and said, this is a Ducati. It was a Thunder Tiger Ducati motorbike. He said it's got a 2.5 2-stroke. I can't have that. So I put a 4-stroke in it. And again, it's got the same clutch system.
Let's have a quick closer look at that. There you go. Oh, hang on, let me just get in focus. There you go.
Yeah. Because that, to me, that's the right way to do a clutch.
Well, makes
you've
sense
got
to me.
you've got the bearing there, then you've got the gear. Whereas if that's hanging out the front,
Yeah.
it's all floppy.
Wow. Look at this. All sort of prototypes at first. I mean, these still can be built. So I mean, if anyone sees this and says I've got a Ducati, I mean, you'd be able to do that for them, would you?
Oh yeah.
Oh, there you go.
And this is again, this is the Runtronic. This is the latest version, which is a lot smaller,
Right.
but on an RCB. When you're converting to petrol from a glow motor, the main problem you've got is the carburettor, because you're going to use half the volume of fuel. So that's why we use this carburettor, which is off our West helicopter motor, and as you can see, it's got a spray bar going right the way across, and I can tailor the needle to give me a nice flow mid-range, because with a normal carburettor you can get the top end right and the bottom end right, and in the middle it's normally all fluffy and sometimes stop.
Okay.
But that's a single 700 milliamp LiPo, and that will run this motor over 3 hours.
Wow. That's phenomenal.
This was another lot of work to build a motor for a stock car. This is the normal clutch setup, which I had nothing to do with. But this guy said he wanted a motor to rev to 15,000, produce its horsepower at 15,000,
Right.
because most of the motors they were using were producing their power at 30,000. So I designed this motor. It's basically a Magnum XLS, but completely redesigned inside, with a longer induction track and a special exhaust. And it turned out that when he'd done his timing to say it was 15,000 RPM, he should have had 2 magnets on the flywheel, but he only had 1. So the motor was actually doing 30,000 RPM,
30,000 RPM.
not 15,000.
Now with stock cars, I mean their engines don't last long. How long would that last, do you think, racing?
Oh, probably get a couple of years out of it.
Really?
Quite happily, yeah. Wow. And these are just standard Moki motors. That's a King, which is a very nice motor. It's old. It's probably 30 years old. But it's got...
Boss has spoken, we've got to move out of the way. Here we go.
This has got Zimmerman disc in a chamber. So that's... it's quite a nice way of doing it.
Yeah. Oh,
But that's a 95
Sounds
cc.
that's got some ground and a Sato at the end.
Yeah, it's an old Sato.
Look at that. Very nice. Right, we're gonna go there because I'm not going to follow through the thing. We're going to look at some even older bits and pieces.
This was my first engine I built from solid when I was 12. All made on a Myford with a vertical slide. So,
I mean, when you say built from scratch, I mean this was literally on a lathe or something, or?
yeah, on a Myford ML7
Wow.
with a vertical slide. It was shit.
I like a man who's honest.
It did about 50,000 RPM,
Right.
but you could put your finger on the flywheel and it would stop. But it was...
Yeah, it was a start. I mean, you know, you don't want to start too early now, do you? Absolutely crazy stuff.
Then late 60s, early 70s, I got into IC cars, and Keith Plested, his famous saying was, it doesn't matter what motor you use because you're never going to be able to put the power down from either an OS 19 or an Enya 19.
Right, it's going to get Wilson.
So what I did was I bunged up the carburettor and put disc induction on the back,
Wow.
and that was...
But then it give you more torque to the ground then, it didn't so much Wilson, I suppose.
yeah, well, it was much better. And then eventually I used a Rossi 2.5 with a pipe. Again, motor laid down, because that's the way the motor sat in the car, flat.
Right.
Which to me sounded logical.
Mm-hmm.
And what I used was a flexing chassis. I didn't have, because in those days you had solid rubber tyres, which weighed a ton, and there was Impex, and he had 13 pounds of lead on his car to make it go round corners. This was the technology at the time.
Technology at the time. Wow. Stick it with lead.
Then I had a go at Pylon racing.
Oh, okay.
And this was a KMB 40, which I didn't like the design, so what I did was I cut the side out and then soldered with gas aluminium solder of the day, and then did porting around and took the baffle off at the top of the piston.
That is phenomenal. And this is all at a young age as well.
Oh yeah, well, no, I was probably about 17.
Oh, really
15,
old then.
16,
You're
yeah.
really old, yeah. You can understand that.
And another thing I used to do, and Basil Miles, who was the original designer at EDs, I used to buy castings off of him, but because I didn't like the way he did his engines, I would then, again with gas aluminium solder a lump in the side, or like this one. Yes, I've got a lump there, and a lump there, and a lump there. The original porting was a slot here, and obviously the holes would turn round.
So covering those up, well, what did that help with the engine? What did it achieve?
Well, no, I didn't cover them up because they weren't there. That was a solid piece of
Right.
aluminium. But what I did was by putting 3 ports in it,
Yeah.
Schnell porting, and this was a Spark one. This would have been about 62, about 62, 63. As you can see, that's the technology for the points.
Yeah,
a normal old car contact breaker. Interesting things that you might be able to see. Under the piston there's actually fins. I don't know whether you can see that.
Let's have a look. Let me just get
Can you
see
see
if I
it
can
at the
zoom
top?
in. Just about.
Yeah, can you see that?
I don't know about on the camera, but I can see them, yeah.
There's some fins on the top for added cooling there.
Wow.
Um,
Technology of the day.
yeah, so that's the porting.
That is fantastic, Alan.
Again, that was rear exhaust, because I thought rear exhaust, even in the boat, was a better layout. And there's the cylinder head with laid out plug just to keep it.
Look at that. That looks like way before its time, doesn't it? So talking about time, let's go to something that's a bit more modern. All right, Alan, we've got a boat, and you designed this boat from scratch. So do you want to tell us about this? Because this looks friggin' awesome.
Was my first foray into tethered hydroplanes, but because I tend to look at things and think, is that the right way to do it? My tethered hydroplane is different.
Right.
It's got two sponsons, but one is underneath the boat,
Right.
and the other one's on a nice arm out the side. Now, this uses a crank web induction. Now, if you've got crankshaft induction, the only way to get more power is to put a bigger crankshaft in.
Right.
That gives you bigger bearings, gives you more drag, etc., etc. So if you've got disc induction, you've got to push that round. Drum induction, again, you've got to push it round. What this uses is the crank web as the actual induction port. So you've got a very large diameter, which is going round anyway because it's pushing the piston up and down. So I look at it as free induction.
Yeah, that makes sense.
And it's a very powerful motor, and to help get it onto the pipe, I had this movable pipe. So as the boat's going round, centrifugal force is forcing this out, which is shortening the pipe.
That's clever. That is very clever. Now, obviously, you can't. I don't think you can see the whole thing here. I'm going to have to move the camera. It's on the stand at the moment, because I thought it'd be a lot easier to show. So, hang on. Let me just hang on. Here we go. Right, do you want to do that again? So when the actual whole thing moves. Look at this.
As centrifugal force goes round, it pushes the weight, which shortens the pipe.
Look at that.
Now, this was actually set up to run spark ignition, but still on glow fuel, because if you do that, you get more power, because what you're actually doing is, instead of the engine going bang when it wants to go bang, you're telling it when to go bang.
That's pretty cool.
Where's
the actual where's the fuel held?
In that tank there.
And how long would that last? That time? It's only a small tank.
You've only got to do 5 laps.
Oh, okay, in the actual race itself.
Yeah, and this uses a servo to operate the needle valve, so you can actually alter the fuel going in while it's going round.
Wow.
So it's using radio, but only to operate the needle valve.
That is phenomenal. That is, wow. That is technical stuff.
And normally you'd have a big wing on the back.
Right.
I'm anti-wing, so I put the exhaust, which you get a lot of power out of an exhaust,
Of course.
pointing up, which is pushing it down.
That you're telling me that you don't need an aerofoil, that would do exactly the same job.
Yeah.
Wow. So then, by doing that, then you're not creating drag with the aerofoil.
That was my theory, and also it's nice and slim.
Yeah, it's very slim. I mean, what's the top of this?
I can go
Yeah.
the top.
I mean, look at this. I mean, when you walk into this shop, I mean, this is a shop. You know, you can look online. There you go, westernuk.co.uk. and you walk in here and your bank manager has a heart attack because there is so much nice stuff here. Plus June won't let you leave unless like you bought something. There you go. That is sleek. So what sort of knots or speed did you get out of this?
I never really
Once
got
again,
its full potential. I won an international meeting with it,
right?
not because it was the fastest one there. The water was so rough, it was the only one to get round.
Oh really? Well, it's like a torpedo. It really is like a surface torpedo.
Well, the thing is that my latest versions are taking this the next stage on.
Right.
I can show you now.
Yeah, let's show us those. All right, Alan, so what we're looking at here?
Right. This is a West 36, which in the tethered hydroplane class holds the record. Not by me,
right?
Because a lot of it is down to propellers, and I'm struggling to make propellers.
Oh, really?
But again, it's got the same format, lay down motor. Normally the motors are standing upright, exhaust down the side, 2 sponsons out on piano wire.
Right.
So I don't like that idea. So again, it's got 2 sponsons, but instead of being on a piece of wire, it's on an aerofoil section.
Oh wow, yeah.
Right.
Clever.
Again, with the exhaust pointing up.
Yep. To push you down.
Yeah. Mini pipe inside. And in actual fact, putting this piece of tube on gave me another 1,000 RPM on the bench.
You're kidding. You explain, because obviously I'm not the greatest technical people sometimes.
Exhausts are a very, very weird setup.
Right.
Because it's not necessarily going to be what you think is the way forward. You know, people go for a big exhaust. In actual fact, on our 25 combat motor, do you want me to go and show you the bits that's in a combat motor?
Yeah. I mean, this is probably going to be a 2 series. It's going to be a Friday feeling and a Saturday extra, because there is so much here. You know, I only come in to get an exhaust made and I'm just in awe. It's like Aladdin's cave. I still want to leave. I might camp for the night. What do you think? I'll get a free pass from the missus. I don't know. This is something else though. I mean, I've never thought of like exhausts. Well, they're saying that, of course, you know, when you sort of get a car or something. I'm sure my brother Nick would tell you all about exhausts on his Scooby-Doo. Or Scooby, should I say, not Scooby-Doo. About what it can change. So let's wait till he comes back. Right, he's back. He's come back. Okay, and what are we looking at now? What are you showing us?
Another thing, this is a backplate cooler, because with a model engine, same as your car will go better on a cold, damp night, because you get more combustible air in the cylinder.
Okay.
Because it's denser. So by keeping the crankcase cold, you can actually increase the performance of your model motor.
Does that work in air as well on the planes? That the more cooling around, the better combustion you get, or is that a bit different?
On the West motors, on the T motors, which are designed for prop hanging, you get a backplate cooler, because it, again, if you can keep the crankcase cold, the volumetric efficiency goes up. Plus, if you're prop hanging, it's only the last 25% of the prop that gives you something like 70% of the performance.
Right.
So that's going to be outside the diameter of the engine. So by keeping it cold in the centre, it works better.
Okay.
Now, this is a standard exhaust.
Yep.
And we use this on the 25. Now you can see it's got a great big hole. What we do is we actually jam that piece of tube up there. So that now has 1 6mm hole. That is for the pressure.
Right, okay. Yeah,
Right.
It goes back to
So
the tank.
all that goes through 1 6mm hole.
Oh, wow.
if I increase that to 6.3, which is a quarter,
right,
by putting this in, we get 500 RPM increase on the motor.
and what stresses does that have on the motor though? I mean,
Nothing.
seriously?
If it's producing more power, it's normally happier.
Right, wow.
Right? Now, if I increase that to a quarter, 6.3, I lose 200 RPM.
That's, wow.
Now, is that crazy or is that crazy?
That is all about tolerance. I mean, you know, I'm a great, as I rather also an RC fan, I'm also an F1 fan, and they're all about tolerances, and it's exactly the same. I didn't know till today, till I saw Alan, and he's telling me that the tolerances are within millimetres of that much power. That is, that's something else. I mean, I am blown away by that. There's probably people that saying, "Oh yeah, I knew that," but I certainly didn't.
Because
when
we do our exhaust, people will get one and they'll say it's not as long as the port on the engine, and they'll spend hours filing it out and probably file it so much that it will drop off, the manifold plate will drop off, knowing that it's going to make no difference at all. If anything, it will slow it down by putting a bigger slot in.
Wow.
Now, this is my latest tethered hydroplane.
Okay. Has this one been raced, or is this the one you're building at the moment?
No.
Oh, look at this. You sure you want to show this? Because your competitors, they might copy you.
No, everybody thinks I'm mad.
That's all right.
But,
You're great.
That's all right.
I'm mad anyway, so it's all good. We're in an asylum.
Now, now this one is a bit more different.
I should put this the right way, really, because obviously everyone's going to be looking at the TV. Let me just stop it there. Hang on. All right, let's take the old pole off, and then we can actually look. So you can actually say, "Go on, Alan. Sorry about that. Interrupting you. Carry on."
Right. Now this one, it hasn't been run, but it sounds right to me. Okay. Because we've got a noise problem. Yeah. What I'm doing two things. The exhaust is coming forwards.
Okay.
Right. And then that is exiting there and there.
Now, does that give you lift as well?
It's going to break away the surface tension on that.
So to make it go faster?
Well, that's the idea. And again, it's one sponsor, but...
Now that's crazy. I mean, surely they could do that sort of thing in big boats, could they not?
Well, they do.
Oh, they do?
Yeah. But
that's crazy, isn't it? Just setting your own exhaust.
And then...
Look at that.
Ground effect.
Yeah. That's going to go some.
So again, that's the idea, that we're going to create suction underneath to hold the back down, because again, I don't want wings. Yeah, I'm just anti-wings. I've never built a boat with wings.
Yeah, we can see that. We can see that. But that is an incredible idea, is that, you know, you've lost your exhaust, but then you found a way to get it sucking down by that, having the two side fins, bottom fins in the water. I mean, what happens, I mean, with the exhaust, I mean, once it's sitting there, does water not get sucked back into the exhaust when you stop?
No.
Okay, it shows how much I know. That's brilliant. Look at this. First, as I say, we only come in to do an engine in Spitfire, and I had to stay. Well, let's find something else Alan can tell us about. Right, Alan, so you're going to talk about your, what's it called again?
Crank web induction.
Right, so I believe everybody else is going to know what you're talking about, so you just crack on, because I'm already blown by science at the moment today, but yeah, go on.
Right. The only way to get more power in a model engine is to put a bigger crankshaft in, if it's crankshaft induction. Now, going from this diameter, which is 12 mil,
I can't
to
really
this
see
one,
those, so yeah, come towards, yeah, that's it there, because I
12 mil diameter.
Yep.
To 13 mil diameter, you can see is a bigger hole. Now it's exactly the same timing in degrees, but it's a bigger hole because it's larger diameter.
Right, okay.
Now,
makes sense.
The problem with that is, as you go up on the diameter, you put a bigger bearing in, right, which gives you more drag. Now with the crank web system, right.
I don't know if you're able to see this, but we'll give it a go.
Now, this has got an 8 mil diameter shaft,
Right.
But a 30mm diameter induction port. So if you look down there, can you see down the hole?
Probably wouldn't see down the hole with the camera. It's not that. Yeah, if you turn it a bit more there, yeah, you can see that. Yeah. Okay.
See, the port's opening up.
Yep.
So if you've got crankshaft induction, you're limited on the diameter.
Right.
If you've got disc induction, you've got to push it round.
Yep.
If you've got drum induction, you've got to push it round. That crank web is going round anyway to push the piston up and down. Now, the other problem you've got is lubricating the bearing. So, because we're cutting a port on the diameter of the crank web, to balance it, we've got to take out some more on the other side.
Yeah,
so if you
really
look
clever.
down there,
let's see if we can show you a picture of this anyway.
so you can see
If I
one
get
side.
in there. Let's just have a quick look. Let's get focus. There we go. Right. Go on.
Right. So one side you can see it's cut through to the face to lubricate the bearing, and then on the other side is where the port is. So by cutting in the side, we've now got a big induction, a 30mm diameter induction port.
That's big.
Right. Now the other thing is, if you look, the exhaust.
Oh, hang on. Hey. It's off centre.
The exhaust is pissed.
Yep.
Because if you've got a side exhaust motor, you've got to put over the top of the bearing and the back plate. If you've got a rear exhaust motor, you've got to pull either side, but also a port over the bearing. If you twist it, like this one is, this is the inside of the bigger motor in the boat, you can see that it's now, we'd have a bearing here, and the ports here and ports there.
So nothing gets in the way.
So nothing gets in the way. You can have, instead of it having to come up to go round, you can take it straight from the crankcase up.
And that gives it oodles
Gives
and
you more
oodles of
power.
horsepower.
And then if you want to, where it does come into the back plate, you can do a Leary back plate like that.
And what does that does that boost it more? Or?
No, it just takes that transfer port there
Yep.
down lower, so it picks up better. But again, it's got a backplate cooler to keep the volumetric efficiency up.
I mean, you are blowing me with engineering skills here, Alan, but I can understand why you hold so many records and still unbeaten today, even in electric you were just chatting to me about, but that is phenomenal. Nice. Right, Alan, so what are we looking at here? Because I mean, this is a special engine. What are you calling it again?
This is a Weatherman class motor,
right?
Which is a vintage class where exhaust are banned.
Oh,
You're
okay.
not allowed to have an exhaust. It's from a standing start,
Yeah.
so it has to take off from the ground. It's control line.
Oh right, okay, yeah, okay, that makes sense now.
So take off the ground and do 5 laps, and it's the average speed. Now this one is a 28 because we do a 25, a 28, 32 and a 36 all in the same crankcase.
And these are all your own designs as well, aren't they?
The crankcase is the old Webra 20 from 1970.
Right.
Which we pushed and pushed and pushed, and the the 36 is awesome, really is awesome. But this is the 28, and we broke the record by 111.9%.
Right. And let me show you. This is the certificate that you got. Now that's phenomenal. I mean, that is a lot of speed, and to break it by that. I mean, we're in the cabinet, by the way. This is the Aladdin's cave, and he's got even diesel engines in here.
Yep, that's another Weatherman class. We held the record with this motor, but then somebody nicked it by .nothing of a mile an hour. But we're going to go back and get it back again.
Fantastic. I mean, I didn't know that you had diesel engines in here.
Yeah. These are the original ED Super Hunter, which I designed in 1972 when I worked for EDs.
Yeah.
And I did the Super Hunter, Super Otter, Viking Mark II, which was when Ken Day bought the rights to the Miles 5. He, for some unknown reason, he didn't want it to look like a Miles 5. So he made this horrible exhaust collector on it, and it was incredibly expensive to make and horrible. So I turned it back into a Miles 5 again. But the Super Hunter has a throttled exhaust.
Yes,
Only a throttled exhaust.
That is beautiful.
Right. Now, the problem with diesel engines is they're very temperature sensitive.
I'm going to be saying that.
They need to get to 70 degrees before they'll run happily. Now, at 70 degrees, because normally you put in ether, and all that does is gets it started. At 70 degrees, you can throw the ether away. You don't actually need it. And what happens if you have a normal carburettor is the motor cools down. So when you open the throttle again, they cough and splutter and things. But if you throttle the exhaust by just stopping the exhaust coming out, it keeps the temperature up, and you can literally, as fast as you can operate that with a quick link, that motor will follow it.
Wow, that's awesome. I mean, yeah.
But what we did a few years ago was, because there's a guy in Canada who's done the ED story, which is not correct. He said there'd been no development on the EDs since the 70s when I left. So I thought, I'll do some diesels. So what,
as you do.
what I've done is I've taken our normal West motor.
Right.
So we take the 25 Combat, yeah.
Okay.
Put a diesel head on it, and we've done again the 25, 28, 32 and 36 and the 52,
right,
all as diesels, either with an RC carb or stunt carb, and they are serious performance motors.
You say the stunt carb, is that, explain a bit more of that to me. I'm
Right,
sure there's people who know what this is.
Stunt carb is either for free flight or control line, where you just want it to go flat out all the time.
Right.
So that's that. And then obviously the RC carb. I do all the shiny bits instead of the purple bits.
Yeah.
Just to make it different.
Well, the purple bit's nice. It's your stamp on things, isn't it? I
Yeah.
like it.
But
Now, as you know, I mean, we was having a chat earlier on about when I was looking for the Spitfire engine, and we was looking at the RCV engine. Now, you've got a little story about horsepower, about what you did with his engine. In fact, let me just stop this and get a bit. Right, so here you go. There's the RCV engines, which is the 90, the 120, and the 60, is it?
Yeah,
60. Yeah. So, I mean, you told me a story about the size of the 120, how big it is, and what you did with the 90. I mean, what did you do?
Well, when I bought the company, the first thing I did was on the 60, because the original RCV 60, which had straight cut gears and in my opinion was horrible, I managed to, with a few mods, got 70% more horsepower out of this version.
Right.
The 120 I was never a fan of, because from the 90 to the 120 on an 1812 prop, there was only 200 RPM more out of the 120, and I thought that's crazy. So I started doing some playing with the 90, and the figures were 5,200 for the 90 and 5,400 for the 120.
Right.
So by playing with the 90, I managed to get that up to 5,800, which made the 120 obsolete.
Yeah.
And it's about 200 grams heavier. It's just horrible for no reason.
Yeah, that's crazy. Now, I mean, I was told that there's a lot of vibration, because as I say, in the Spit, I was looking at this so we could make it and fit an exhaust. I mean, what makes the vibration then? I mean,
Right. If it's one of the original straight cut UK manufactured ones, they were horrible. When the business was offered to me, I said no straight away. But I bought one of each, and when they went to the skew cut gears, it changed dramatically. But if you don't set them up correctly with the clearance, on the tip of an 18-inch blade, you need less than 1 millimetre of movement. If you've got more than that, they will make a noise, they'll vibrate, they're horrible. But if you can keep that tight, they're a lovely motor.
Yeah, I mean, I think they're great engineering.
The other major problem you have is cooling. Now, when you open the box, the first thing you see is cooling for RCV, because the main problem is they're probably smaller than the spinner you've got on the front. People say the fins are going the wrong way. They're not going the wrong way. What you need to do is get air in the front and then turn it round the corner.
Right.
Now, what RCV used to say was just bend a bit of alley, but air is going to take the shortest route. It's, instead of going round the corner, it's going to go round the sides. So you need like a 3-sided box, so that air goes in, can't come off the side, it's got to go round the corner. And you need more out air than you've got in, because the way a hot air balloon works is the air expands when it gets hot. So if you've got the same outlet as you've got in, then it's going to be a dam, because the air's got bigger and it can't get out quick enough.
That is fascinating.
And we have some really crazy people. There was one guy in Germany who sent me a video of all the ducting he'd made in his plane. Perfect, everything was perfect. And then you see it staked out on 2 screwdrivers with no cowling on the front, and he's running it, and he's got a tacho and he's adjusting it and thumbs up to his mates, and then it stopped. And my comment was, I'm surprised it ran that long, because it's just sitting there getting hot.
Yeah, get no air
I
going.
test run every motor, and I've got a U-shaped piece of 22mm copper tube with holes drilled on the inside, and that sits underneath the motor, and I start the motor up and turn the air on, because you need to cool it.
Yeah, well, it's like any engine, isn't it? I mean, it's without cooling, it's I just actually boosted the. There we go. Right. Now on here.
Well, this one.
Yeah.
This was a motor I did for the Club 32 Pylon racing.
Right.
And they said, because San Yi, who used to make ASP, SC and Magnum, just literally disappeared off the face of the earth, they asked me if I'd do a 32, which I did. And on an 8.8 I got 17,500. Wow. But they only wanted 15,500. So for the first time ever, I've had to detune a motor to keep the people happy.
Well, it probably lasted twice as long.
No, probably not, because my engines don't wear out anyway.
Right.
But that's been the most successful motor for the last 3 years. It's won the championship every year, and it's first, second and third all the
big
time.
boys up there as well. So which one? Okay, let's go back to, as we know on Dad's RC Hangar, it's all about me. Where's my engine that you're going to put in my Spitfire? Which one are we going to go for?
We're going to go for this one.
There we go. Right, so I mean, if you could talk a little bit about this, because obviously my mind is blown today, ladies and gentlemen. Alan is like an encyclopedia of engines, and I feel like I've been to not only a history class but an engineering class. Honestly, let's just talk about the engine. So what's special about this? Why is this going to sit in my glorious Spitfire?
Because it's designed as a T motor, which stands for torque.
Right.
We always do 2 motors, a high RPM motor and a high torque motor, because OS, ENIA, whoever build a motor. Here you are, do what you want with it.
Yeah.
So if you're going to fly one of our Magnum or Velocity aeroplanes and put an 8.8 on it at 20 odd thousand, and then take that same motor and put it in a hype and run it on a 13.4W at about 13,000, it's not going to work.
Right.
So we do one motor that's going to do high RPM and one motor which is going to be high torque. And I'm doing him the high torque motor, which is the 52 T2.
There you go. And you're going to be making an exhaust for me.
Yep.
Which you did laugh at because you saw the cowling this morning.
One of the major problems we have with people and their scale exhaust is they don't realise that a motor doesn't have to be standing up vertical, 90 degrees or inverted.
Now this was an eye-opener for me because, as I say, I'm still a noob in this, and I thought it just needed to be sort of like 12 o'clock or 6 o'clock.
Right. Now, your problem is it's the gap between the face of the exhaust and the cowling. And you need as much space as you can get. So if you can rotate the motor, you get a lot more gap, and then you can get a nice manifold off. With Ripmax, they had a Mustang, and they asked me if I would do an exhaust to their drawing, and they sent me the drawing down, and I said no straight away because I knew it wouldn't work. They sent it off to China, and they had exhaust made, and they didn't work. And they landed up coming down here with the aeroplane and said, make an exhaust for this.
And you did, obviously.
And what we did was we swung the motor.
Right.
Now that give us, because we was looking at, I think, 20 mil from the face of the exhaust on a 3W80 to the cowling.
Right.
Now you can't do a lot with that. You've got 1/4 inch of manifold plate, which is just to bolt it on. So what I did was I made up some bits of aluminium strip with 2 holes in, which mounted on the 4 engine mount plates, and just twisted the motor around, which now came up inside the cowling more, so it wasn't even sticking outside the plane so much, and it gave me 2.5 inches to the side of the airframe. So that allowed us to do a manifold into a box, into the nice pipes out the side. And it's really annoying when people just don't think it can be a little bit different. If you look at our aeroplanes,
Let's have a look here. I'm going to take you up because it's actually, hopefully the camera just doesn't fall off, but I think I'm showing it. Am I showing? There you go.
right, that's on our hype, and the head's about 7 o'clock. But it does mean that the pipe sits down the centre of the airframe. It's like
awesome.
it's supposed to be there. Even on our Cougar.
Yeah, we like the Cougar. I mean, I do like this Cougar. Oh, hang on, I'm throwing the planes about. I'm smashing the plates up. Shush, don't I have to buy stuff. Okay, there you go. Once again. Right, Alan, listen, thank you very much for taking on this job for the Spitfire and bits and pieces. Now, Alan has taken me around the different places and bits and pieces around here that we haven't filmed. And it's not only the West engines that they make, but they also make some serious fuel. Now, do you want to quickly tell everyone about your fuel while we're here, Alan? Of course you do.
Right. Well, when we started making fuel in 92, I looked at all the oils on the market and wasn't very impressed, because late 60s, early 70s, there was the caster crisis, because until then everybody used 80-20 or 75-25, and Castrol had just come out with their synthetic oil, which was called MSSR, and I was running boats with an HP 61, and after a half-hour race you could feel the step in the bore. It was horrendous stuff, more like liquid carborundum paste than a lubricant. and after a bit of struggling I found an oil, and it was expensive, but I slowly went down and down and down until I was running at 1% oil, and it was superb. The boats run cold. It was absolutely brilliant, and I did go up to 2.5%, not because I've had any problems. It was just that I was panicking, thinking this can't be right at 1%. Now it does have minor drawbacks. On the way in, it eats silicone tube. On the way out, it eats KMB epoxy paint, solar film, aura cover and fiberglass.
Jeez.
So it's a wonderful lubricant with a minor drawback. So when we started making fuel, I knew what I wanted, but I obviously couldn't use this oil because we may have had a few complaints about planes disintegrated.
Oh, I can imagine.
So I tried all the Flukes oils from Germany, because Germany had this idea of using methanol on their police cars, fire engines and ambulances. So they got Fuchs to make an oil which would mix with methanol. I tried all of those, and they eventually became Aerosafe, Aerosynth, Aerosynth 2, Aero Running, which Grautner marketed, and didn't like them. I tried all the American oils, and I even got onto Castrol and had any oil that would mix with methanol, including one called Icematic, which was for freezer units.
Wow.
And nothing was any good. And one day I just phoned up this small independent oil company, and the guy said, give it a go. And after 6 months of me saying, no, that's not very good, they came up with this lubricant, and it is different. They only make it for me. It is just a completely different animal. If you see our planes flying, there's hardly any smoke because the oil doesn't burn, and we're just using today's oil technology instead of 17th century technology, which is what caster is. You know, caster's wonderful stuff, but it's not very nice on your motor.
No, I mean what about the price? I mean, is it hike the price up on like, you know, because people just want to go and fly. They'll, like myself, so I'll pick up some from the local hobbyist store or anything. I mean, how does the price differ from that? You
with the leading supplier, we are only £10 a gallon cheaper.
Oh wow, okay.
Our 10%, which is our most popular fuel, is £17.35 for a gallon.
That's pretty good.
And if you buy 4 gallons, we can drop it on your doorstep next day, post free.
So how can people get? I mean, this is on your website, isn't it, to buy?
It's on our website.
And
there is a problem.
Okay.
Because all our fuel goes out in what's called a UN combination pack. The bottles we use with the tactile warning and the CRC closure and this number on has to go in this box with this number on to make a UN combination pack. So we can only supply multiples of 4.
Right.
So 4 gallons of any mix, doesn't matter, you can have a gallon of 10%, a gallon of straight, a gallon of 25 in the box, doesn't matter what it is, as long as there is 4. That is post free. If you have 4 half gallons, obviously 2 half gallons work out dearer than a gallon because we got 2 bottles, 2 caps, labels, etc. We can do that 4 halves, but we charge £4.50 towards the £10 carriage that it costs us.
That's, I mean, to be honest with you, I mean that's not a lot when you think about some people that when you buy a model or anything, the carriage absolutely kills you. So I mean, for that is fantastic. So, and you got plenty. Obviously, you make it yourself. You mix it yourself,
here
don't you?
On the premises.
Well, maybe when we come back in a couple or a few weeks, whenever. I mean, how long do you reckon the Spitfire's going to take? Just a roughness.
I would think probably 3 weeks, because I've got to sort out engine mounts. Got to build the engine, get it mounted, and then worry about where the bits go.
Right, so in about 3 weeks then we'll come back and we'll have a look at this the fuel, and obviously I'm definitely going to have some myself to use on your West engine that you're going to put in the Spit.
The thing is, if you use our 10% Pro on a West engine, we give you a genuine 2-year warranty. That's including bearings, everything.
And it doesn't matter how many flights you do, obviously.
No.
That is fantastic. So, I mean, you know, other than your West engines, which look fantastic, I mean, what you told me has just blown me away. And the fuel, what else, I mean, what else are you selling here?
We do the biggest range of exhaust systems in the world,
right,
because we do it for cars, boats, aircraft. We do scale exhaust. They're a pain, but it does finish an aeroplane.
Yeah, well, I think so. I think, you know, if a lot of people that I've met sort of like just want to throw the plane up in the air and fly around, but I'm more of aesthetics as well as what it does. So, I mean, it's just fantastic. So,
if you're building a nice plane, then it finishes it to have an exhaust, even if it's a normal sort of fun fly or aerobatic plane. If the exhaust looks like it's supposed to be there, it's just so much nicer.
Oh, of course it is. It was. There are a lot of things it's scale, a bit like the Spit. I mean, and as you said, you know, the exhaust matters with power as well. So, you know, and obviously you can offer that advice here. So if someone says, I've got this engine, I've got this plane, I want the best sort of like out of the engine, but also look aesthetically pleasing, you can tell them what they need, obviously. Fantastic. All right, Alan, well listen, I've taken you on June's time up. I've drunk all your tea, I've ate all your biscuits, and I've got to get out of here and try and get this up this evening. So listen, thanks for your time, and we'll catch up with you in a few weeks.
Okay.
Cheers then.
Bye.
And back in the hangar. Oh yes, if you've stayed this long, thanks ever so much, because the words from Alan Greenfield are golden. I mean, what if you didn't know anything, it wasn't worth knowing about in my book. You know, thanks ever so much, Alan and June, your lovely wife, for the time of day that you gave me. We was there almost all day, just chit-chatting about everything and filling my brain with knowledge. My brain hurts. I have a brain ache. Wow. I mean, the guy is just a legend in my book. I mean, you know, making all them exhausts, the engines, the fuel. I mean, you know, what else is there to make apart from the actual aeroplane itself? Which he does. You know, fantastic. I'm so looking forward to it. 3 weeks, unfortunately. My Spitfire fuselage and the Cowling are with him at the moment. I'm already upset and sad. I miss them terribly. And I've got to wait 3 weeks, but what a wait. We're going to have a scale exhaust on our Spitfire, ready to maiden. Hopefully this year. At the moment, it's been nothing but rain in May. It is the most wettest May in the UK I've known. In the UK, we normally have what's called April showers. I think we're getting it in May showers. So let's hope that June, July, August and maybe September is going to be some great flying weather. And obviously aim towards my certificate. So listen, I'm not going to waffle on any longer because we've just done an hour's show on that Friday feeling. But what a big Friday feeling. What a lovely guy, Alan Greenfield, a legend, a living legend. And of course the boss, his wife, June. Yes. Thank you, June. Lovely cup of tea from your staff. That I've forgotten your name and I do apologise, but a lovely guy. I've named him Rivets because what he doesn't know about a Spitfire is not worth knowing. So, and he could probably like Alan said, he could probably tell me how many rivets are on a Spitfire. So his name is Rivets. So we'll be back in a 3 weeks and we'll take another look at all the other bits and pieces where he makes the exhausts and the engines and even the fuel, and give you a little insight of what goes on there. But don't forget, go and visit their site, and if you do want a bespoke exhaust or get one of the engines, then have a chat with them. They've got all the time in the world for you, as long as you buy an engine or something. I will leave a link to their website below, but give them a call and I'm sure there's something that you need and something they can offer you. So until that next Friday feeling, be safe, keep safe and have fun, and if you can fly, do so. Thanks for stopping by, I really appreciate it. See ya, bye bye.